Hi everyone, week 1, distance learning some factoring here. I hope you all are doing well. I'm still thinking about you guys constantly and wish we could be doing this together since, as I said before, this is my favorite unit to teach. I look forward to this unit every year, so I'm just going to have to embrace the new format that we've got going on here. Okay, so factoring. So the biggest thing I want to talk about factoring as an overview is I was giving you things in factored form to start, and I was asking for you guys to give me the expanded form. So we were actually going this way the last unit, where you'd have to do the distributive property and you would write it as negative 15 x to the third y plus 12 x squared y squared. Now we're going to go the other way. So now you guys are almost going to be like the teacher, and you are going to take the expanded form and write it with the parentheses and write it in factored form. The way we're going to do that is finding the greatest common factor. There's a method called the grouping method. There's the trinomial method, the British method. There's a lot of different ways, and it all depends on the amount of terms that you have in your polynomial. We're going to start off really basic here. We're going to talk about just factoring out the greatest common factor, the GCF. That is the first step of factoring all the time. The first step that you should be doing for factoring, no matter what, is trying to take out a GCF. It just makes our polynomials a lot smaller, and it makes us, using the other methods of factoring, it makes it a little bit easier on us. So remember, expanded form means you don't have any parentheses, where factored form means you have parentheses. So we are trying to create this factor form. Okay, that's what we're trying to create. We're trying to create the parentheses. All right, day 1 notes. So I know technically we're doing 2 days in 1 week, but it happens. So this will be our day 1 notes. So factor is to write a polynomial as a product of other polynomial expressions. The first method for factoring is taking out the GCF. GCF stands for the greatest common factor. And it's the greatest number or variable, so we'll call it a monomial. It's the greatest monomial that is a factor of one or more of the other monomials that'll be inside of the parentheses. So looking here, these are some basic examples. You might have seen some of these in pre-algebra. At least I hope you saw some of these in pre-algebra last year. Definitely with the numbers, probably not so crazy with the variables. So your GCF here. So what you're trying to do is you're trying to find the different factors of these, and then you're picking out what they have in common. So if I do 10p squared, 10p squared, let's start with the 10. So the factors of 10 are 1 and 10, because 1 times 10 is 10. And 2 and 5. So those are my factors. Okay, so we like to write a list. And then I have 2 p's because it's p squared. Then looking at 2p to the third. So the factors of 2 are 1 and 2. And then I have 3 p's. What you're doing is you're finding the greatest number they have in common, which is the 2. And the greatest number of p's they have in common. They have 2 p's in common. Okay, I'll kind of try and write this in a similar way. So your GCF is 2p squared. You could have probably figured out that the greatest common factor was 2 easily without doing the list out method. For the variables, you're always picking the least amount of variables. So since this was p squared up at the top, that's the one that you're going to choose. So coming over here to our next example, 18 and 20. So the greatest number that goes into both 18 and 20 is going to be 2, right? Because 20 is 2 and 10 and 4 and 5, and 4 and 5 don't go into 18. So 2. 2 is going to be the greatest number that goes into both of these. And then you have an A here, 2 A's here, and you have an A and a B here. So the most they have in common is they have an A in common. That's the most. They do not have a B in common. So your answer is going to be 2A for your GCF. All right, moving on to your next one. So 5 and 4 don't have any factors in common besides 1. And there's no B here, so they have no factor in common when it comes to a variable. So your answer is just 1. Okay, so their GCF is 1. Looking here, 42 and 56. So 42 is divisible by 7 and 6, And 56 is also divisible by 7. So you would think 7, but let's take a moment and check all the other numbers. So if I go a little bit bigger than 7, I can actually do 14. So 14 goes into both of these twice. So if I do 56 divided by 14, it gives me 4. If I do 42 divided by 14, it gives me 3. So 14 is the biggest number that goes in both. Now let's look at the variables. So this one has 3 m's and an n. This has 3 m's and 2 n's. So the most they have in common are these 3 m's. So m squared, or m cubed, excuse me, is in our GCF. And then they have 1 n in common, not 2 of them, just one of them in common. So you put an n there on the ends. 6, 18, and 12, so those are all divisible by 6. And then the most amount of w's they have in common is the lowest exponent, which is w. Okay, or you could list them out like I was doing before. And you could realize that they only have the one W in common. Whatever's easiest for you guys. There's supposed to be a comma there, so I kind of just squeezed it in. Hopefully it showed up on your end. So the GCF of the numbers 7, 7, and 7, the greatest common factor is 7. Looking at the variables, so you have to pick the lowest variable. So this is t squared, t, t. So t is my lowest one. U squared, u to the 7th, u. U is my lowest one. V to the 6th, V to the 7th, no V. So I can't have a V in my GCF. But like I said before, you can list them out, and I'll show what that looks like in 1 second. You can list them out. So I took a second there and I listed them out, and you can see that I've got a T in common, and I have a U in common for all of them. Okay, that's how I get TU. So you can do it that way, or you don't necessarily have to. Last one here before we move on. So I see in my numbers, I've got 10, 10, 10, and 20. So the greatest one they have in common is 10. My lowest D, well, actually, there's no D in this one, so I can't use D, okay, because this one actually is D to the 0 power, so there's no D there. My lowest F, there's no F here. So since there's no D's or F's in all of them, I have no variable terms that I can take out. Once again, you can list them, but you'll see that you can't pull an F out of this term and you can't pull D out of this term, so you won't have any variable terms there. So 10. 10 is your GCF. What does that look like for us? So that was just kind of listing out monomials so we can figure out what the GCFs are. Now we're actually going to pull them out and write parentheses. So what you're going to do is these different steps, these 4 steps. You're going to determine what the GCF is. You're going to write the GCF on the outside of the parentheses and then divide each term by that GCF to figure out what should be left inside the parentheses. And then you can always go through and check by multiplying by using the distributive property. So let's look at here. So looking at these monomial terms, this is a monomial term, this is a monomial term. 10 and 5, the GCF for 10 and 5, okay, the GCF is most certainly a 5, okay, and then I have 2 Y's and 1 Y, so I have 1 Y in common. So my GCF, if it was written before, like these types of problems, I would say it's 5Y, but now it's not. Now they're actually giving me a polynomial with addition and subtraction in between. So I'm going to write my GCF on the outside and then put parentheses there, because whatever's left over is going to go inside the parentheses. So when I say whenever's left over, that's when you divide each term by 5y. So if I divide this by 5y and this by 5y, 10 divided by 5 gives me 2. So there is 2 left over. Y squared minus 1y, so you were canceling them out, gives me 1y left over. You can also think about it as you're pulling 1y to the outside, so you're left with 1. Negative 5 divided by 5 is a negative 1. These y's cancel each other, or you're pulling that y to the outside. So this is our answer here. I do suggest that you do a quick distributive property to check. So 5 times 2 gives me 10. 2 y's give me y squared. 5 times negative 1 is negative 5, and I bring the y over. So this checks out. All right, let's look at a few more. So looking at this one, I can pull out a 12. Okay, so I'm going to divide these by 12 because that's my GCF, and my lowest exponent of g's is 3. So I'm going to write that on the outside, and then I'm left with 3 and 1g, because I pulled 3 to go on the outside, and there was 4 originally. Oh, I shouldn't have put my parenthesis there because I still have to do negative 12 divided by 12 is a negative 1. All my g's cancel. So you do need that placeholder there. If you were just to write this like this, when you go to use the distributive property, it's not going to give you that second term. So this is actually not going to work. We need to have that placeholder of a positive 1, or in this case, a negative 1. Looking at the next one, so 42, 14, and 7, they're all divisible by 7, but I can't take any q's out because this has 4 q's, this has 3 q's, this has no q's. Okay, so I'm going to pull a 7 on the outside. 42 divided by 7 gives me 6, so that's going to be 6q to the 4th plus 2q to the 3rd minus 1, because we need that placeholder. If you have a 3-term polynomial or a trinomial to start, you have to have a trinomial to end in your answer after you pull out the GCF. All right, let's look at the next one. So 2, 4, and 12 are all divisible by 2, so that's going to be my number that goes on the outside. I've got 3, 2, and 1, so I pick my lowest exponent. That's going to be an x. So my GCF is a 2x. Leaves me with a 1x squared, but you don't actually need the 1 there, so I'm just going to write it as an x squared. If you leave the 1 there, it won't be wrong. Minus 2x, because 1's pulled on the outside, plus 6. And you can do a quick distributive property there to see that they're going to be equal to each other. The next one, okay. This is the first time where we've had a leading coefficient be negative. We never want to factor with a leading coefficient of negative. So you're actually going to pull out a negative number to make the leading coefficient inside of our parentheses positive. So I'm going to pull out a negative 9 from all of these terms. That way, inside the parentheses, it'll allow me to start with a positive. And then for v's, I've got 3, 2, and 1, so I'm going to pull out the 1v. Negative, so write that on the outside, negative 9 divided by negative 9 is a positive 1, but I already said you don't need to write the 1 there, but you can if you want. V squared minus 1v, positive divided by a negative, positive divided by a negative, minus 1. And like I said, you don't need to write the coefficient of the v's, but you do need to write the minus 1 at the end. So you can give me any of those answers, but the answer keys will probably end up looking like the second one. All right, so to reiterate, you want to make sure if it's a front number is negative, if the leading coefficient is negative, you divide everything by a negative number so that inside your parentheses you have a positive. That's going to be very important as we continue to factor. This is not in standard form. Remember, standard form is decreasing exponents. So I want to make sure that I put that a squared first, then the 63a, and that constant term goes on the end. I can divide all of these by 9, but since that front number is negative, I'm going to divide them all by negative 9. And then no a's because there isn't an a with the 27. So I'm pulling out a negative 9 in my GCF. It gives me a positive, because 2 negatives make a positive 7a squared, which is what I want because I want the leading coefficient to be positive, minus, because 63 divided by negative 9 is a negative, 7a, minus 27 divided by a negative, positive divided by a negative is a negative 3. You could also write it as plus negatives if you want as well. Last one here. Okay, once again, that front negative is front number is negative, so I definitely know I'm going to pull out a negative. Don't have to worry about standard form for this one, guys, because it's got more than one variable. So I need to pull out a negative, and all of these are divisible by negative 6. So I'm going to divide them all by negative 6 for my numbers. My lowest a term is an a squared term. It could be that one or this one. And my lowest b term is just a b. So that's what I'm going to divide these by. Negative 6a squared b. Doing that gives me, write that on the outside. And then when you divide all those out, you get a positive 6b to the 6th, a positive 3a to the 3rd b, and a positive 4. And once again, you can check that by using the distributive property. All right, I'll see you in our live Teams chat very soon.